This is Algebra 1, test number 5, study guide, picking up on part 2. Says evaluate negative x plus 1.6 when x's value is 1.1. So what we're going to do is take that value 1.1 and in place of x, plug it in. There's a negative in front of the x, though, so it's negative 1.1 plus negative 1.6. So now what we have is addition of the same sign. Both of them are negative. So you put them together, you add them. 1.1 plus 1.6 is 2.7, and you keep that common sign since they were both negative. You keep it as a negative 2.7. Number 13 says evaluate the absolute value of negative x minus 2y when x's value is negative 4. So in place, again, substituting in place of x, we got a negative and we plug in a negative 4 minus 2 times y. Y's value is 5. So all of that's going to be the absolute value of all of that. So when we look at what we got going on in there, multiplication comes first. This acts like negative 1 times this. So a negative times a negative, or any negative negative, is a positive 4. And negative 2 times positive 5 is negative 10. So we got something that looks like this now. We learned yesterday that when you do subtraction, you can treat it as if addition of the opposite. So we can look at this as if it says 4 plus a negative 10. Doesn't make a whole lot of difference, and you don't need to do that. It's just the way we can follow the same rules. Opposite signs, one positive, one negative. Take 10 and subtract 4 from it, and you get the number 6. Then take the sign of the larger absolute value. 10 is farther away from 0 than 4 is. It's negative, so it'll be negative 6. But it's still talking about the absolute value of that, which means how far away from 0 is the number 6. It's 6 units away. It'll never be a negative value. Distance is never a negative value. So in this case, it's positive 6. 14 says simplify negative 1 minus 8 using a number line. Something as simple as this. Negative 1 is where you're going to begin, so right there. Minus 8, you need to know your minus numbers are to the left and your positive numbers or your plus numbers are to the right. So if we start here, we want to subtract 8. We're going to go over 1, 2, 3, 4, 5, 6, 7, 8 more times when we move it from our negative 1. 8 times, and we'll have negative 9 there. 15 and 16, we're using an algebraic expression for the phrase given. First one, number 15, says the sum of x and 12. Sum means plus, so x plus 12. Algebraic expression. The product of w and 12. Product means to multiply. So you could do w times 12, and that would be perfectly fine. Or you can make it a little neater looking and say 12w. Both of those are correct. Same thing with this one, except they just don't give you a variable. It doesn't make it really any more difficult. It says 3 minus a number. Minus a number will say x. So 3 minus that number x. The quotient, this one's a little tougher because you got to do 2 operations. It says the quotient of 8 times a number and 12. 8 times a number, we'll do that part first. A number, let's call it x again. 8 times that is simply 8x. 8 times x. Then it says the quotient of that and 12. So 8x, quotient means to divide. So 8x divided by 12 is one way you can write it. A little bit of a cleaner, neater way would simply be 8x over 12. But both of those, again, would be acceptable and accurate. Writing this fraction in simplest form, 18 over 32. In order to do it over simplest form, you want to find a number that goes into both of those. Your factors of 18, I always use the smaller number, are 1 and 18, 2 and 9, 3 and 6. And those are the only numbers that go into it because 4 doesn't multiply by anything, neither does 5. So you just want to see which one is the biggest number out of those that goes into 32. Well, we know 18 doesn't multiply by anything give you 32 because 18 twice is 36. 9 doesn't because 9 times 4 is 36. It's not close to 32. 6 doesn't multiply by anything because 6 times 5 is 30. And we know 3 times 10 is 30. That doesn't work either. So the biggest number we can use is the number 2. 2 times 9 is 18, and 2 times 16 is 32. There's your fraction. Number 20 and 21 are kind of backwards of each other. 20 says to write 6 times 6 times 6 using an exponent. 1, 2, 3 is how many times it's multiplying by itself. So it'll be 6 to the third power. 10 to the fifth power in standard form would be 10 times 10, 5 times. 10 times itself 5 times. 10 is an easy number because this could actually be the answer written in standard form. Or you could go ahead and multiply that by itself. All you need to do to multiply that by itself is to say 1 with 5 zeros behind it. So 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 more is 100,000 is what it winds up being. That's why 10's an easy number to do that with. Most of us can't multiply other numbers nearly as easily. Number 22 says 0.006 times 3.3. So if we just stack them, usually it's easier for most of us to do. 3 times 6, or it's probably even easier if you stack it the other way since it's just a bunch of placeholders. 3.3 times 0.006. So 6 times 3 is 18. Carry your 1. 6 times 3 is 18 again. Plus 1 more is 19. All those placeholders, you don't have to multiply by all those zeros. What you do need to do, though, is you need to count how many times the decimal has to move. It has to move once for this one, and it has to move 2, 3, 4 times total with that one. So from here, it's going to move once, twice, 3 times, and we got to go one more time, which means we have to add in a 0. So it's 0.0198. Adding and subtracting fractions, the bottom number has to be the same. The smallest number that 6 and 5 go into in order to make like denominators is the number 30. We have to change it to the number 30. So 6 needs to multiply by 5 to give us 30, which means the top number 3 has to also multiply by 5. 5 has to multiply by 6 to give us 30, which means the top number also has to multiply by 6. Now we got the same number at the bottom. So we'll keep that number 30 at the bottom, and we'll add 15 plus 6 and get 21. Now the number 3 goes into both of these. 3 goes into 21 7 times and into 30 10 times. So your simplified version of this one would be 7 over 10. The same thing has to happen with number 24. You need to have like denominators. It's smaller for this one, though, because both of them go into the number 12. The least common multiple of 12 and 6 is 12. You don't have to change this one because it's already 12. This one, on the other hand, has to multiply by 2. So does this one. So that one becomes 2. So we have 12 at the bottom. Now we're going to keep it like that. 8 minus 2 is 6. And the number 6 goes into both of these, into this one once and into this one twice. There is your simplified fraction. $25, you do not have to have like denominators to divide. That's a division in case it looked like an addition to you. 1/2 stays the same. When you divide fractions, division becomes multiplication, and you use that fancy word reciprocal to flip 5 over 8 and multiply it by 8 over 5. You can multiply straight across, or you can cancel it right now. It doesn't matter. You're just going to have to simplify it later. 1 times 8 is 8. 2 times 5 is 10. The number 2 goes into both of these. This one, it goes into it 4 times. This one, it goes into 5 times. If you canceled it out earlier, you would have gotten 2 going into both of them, 1 at the bottom and 4 on the top would have given you the same 4 over 5. 26 tells you to write it as a fraction in simplest form, 0.52. This is the tenths place. This is the hundredths place. So we have it in hundredths place already. So 52 hundredths is how it's actually given to us. When you make it a fraction, that's what it will look like. But it tells us to write it in simplest form. We might not know what the largest number or the largest factor 52 and 100 share, but we can look at it quickly and determine that they're both even, which means the number 2 goes into both of them. 2 goes into 52, when we know 2 goes into 50 25 times, so it goes into 52 26 times. And 2 goes into the number 100 50 times. So now if we look at it, now we're just dealing with smaller numbers. Think of your factors of 26. 1 goes into it, so does 2. 3 doesn't. 4 doesn't. 5, 6, nothing else does besides 13 and 26. So the number 2 doesn't go, or the 2 goes into it one more time, excuse me. 2 goes into 26 13 times, and it goes into 50 25 times. So if you took 4 as the greatest common factor, you did that in one step instead of 2. But most of us are more comfortable using 2 and just doing it in 2 steps. It takes a little bit longer, but it's a whole lot easier mentally to do. 27 tells you to evaluate u plus xy when u is 20, x is 10, and y is 10. So in place of u, we're going to sub in 20. In place of x, we're going to sub in 10. And in place of y, we're going to sub in 10. It's right next to it. So what we have is 20 plus that times that. Order of operations says to do multiplication before you do addition. So 10 times 10, everybody in here could do quickly, is 100. And 20 plus 100 is 120. And then the last problem, number 28, tells you to evaluate the expression AB squared when A is 3. So in place of A, we'll plug in 3. And B is 4. In place of B, we'll plug in 4. Those are multiplying by each other since they're right next to each other. And they're both being squared. Order of operations tells you to do what's in parentheses first. 3 times 4 is 12. And then 12 squared means not 12 times 2, but 12 times itself. 12 times 12, which is 144.